All right, so we've been spending some time working on doing some basic data manipulation, transformation. And several lessons ago, we talked about some different types of data that we can work with. Numeric data, integers, booleans, and character strings. Now, character strings offer kind of unique complexity in doing analysis with them. So we're going to spend a little bit of time here digging into some additional stuff we can do with character strings to identify particularly patterns that exist within them. All right, so to work through this, we're going to go ahead, we're going to load the tidyverse. And within tidyverse, there's a certain package of interest, and it's called string R. And string R provides a lot of functionality to work with strings. Now, to illustrate what we can do, we're going to use the complete journey data, and in particular, we're going to focus on the transactions and the products data. All right, so often we have character strings in our data that are long, so they're usually not just short, blue, red, yellow, short strings. They can often be long, like descriptive fields. And many times they can be messy, where there's not consistency in the values that are represented in those strings. Okay, and historically, we've been able to do a lot of this functionality where we're working with strings in base R, but it's a little bit frustrating, and the syntax has inconsistencies depending on the function in the application that we want to apply. So the string R package is a package that basically modifies a lot of these string manipulation tasks, and it makes them far more consistent in applying them. And string R also is a tidyverse package, so when you install tidyverse, you installed string R, and then when you load tidyverse, you also load string R. All right, so the one thing to point out is all the string R functions are very consistent in that they start with str. So basically string and then underscore and then the function that we want to apply. And when we look at a lot of the functions, they make sense, right? Do we want to remove parts of the string? Do we want to detect some pattern in the string? Do we want to replace a value in the string with something else? Do we want to count the number of characters that are in a string, right? A lot of these functions are very logical in what they do, and by their name, you can pretty much intuitively understand what the objective of those functions are. All right, so to illustrate some simple examples, let's look at a string here. And I've got this in my R console. I've got this vector here, this vector of X that's got frozen meat / meat dinners, meat, miscellaneous, and cereal, right? So some basic functionality that we can do with the string R package is we could just force everything to be lowercase, right? And there's also a stir to upper, you could do stir to title case, stir to sentence, and so on, right? So we can just convert the case of the characters to lower to upper, title case, and so on. Maybe we want to extract certain parts of our string, and we can do that with the sub, basically stir sub. That means get a substring from our character string, right? So say I want to get the first 4 letters of each element or each string, right? So we get FROZ, FRZN, meat, and so on from these first 4 elements. We can detect if a certain pattern exists. So if I use this stir detect, notice how if this word that we supply is somewhere within that string, it returns a true. If it does not exist in there, for example, cereal, there's no meat in this string, right? We get false. We can replace things. Say I want to replace meat with non-veggie. I could do that with the stir replace function. And what you will notice here is that what stir replace does is it actually replaces the first instance of that. So let's look at this one, this frozen meat and then slash meat dinners. What ended up happening was we replaced the first instance of meat with non-veggie, but we still have this second one. So there's another function, stir replace all, that will replace all instances of meat with non-veggie. So now we see in that second element, we got non-veggie and non-veggie. So both of the instances of meat were replaced. All right. So what's useful about these? Well, the primary use cases that we run into are often we want to find a certain pattern that exists within a string. We want to be able to extract and replace certain parts of a string. And then we want to apply regular expressions. And regular expression, this number 3 here, is really just an advanced use case or advanced capability to do number 1. Okay, so regular expressions are all about matching certain patterns within a string. Now I'm going to illustrate some basic examples in the slides, but honestly, the lesson chapter goes much more into detail. So definitely take a look and read through that chapter to get a more full understanding of how these capabilities work. All right, so something that's really useful is notice how we can use stir detect, and that's going to return a product category. So we want to take products and product category. So if we look at a particular vector and we do detect, we get this true false in response. Well, the nice thing about that is we can put this into a filter statement. And what's going to happen is filter is going to look at where all those elements are true, and it will return those observations. So in this case, we're looking at the products data. We just select certain 2 variables of interest, and then we say get all of those observations where product category contains the word meat, right? So now all those observations in here that are returned includes meat. Another handy way of including these stir functions within dplyr functionality is to create a new variable, right? So here, what I'm going to do with the products data is I'm going to create a new variable called meat. And what that's going to do is just detect if it's true or false, if meat exists. So if I were to run this, let's go ahead and we see that we have this meat product here, right? So basically, does meat exist within this element? And in all these cases, it's false, right? But what I can do now is I could get the count and the proportion. So I could actually use these true false. Remember, true is equal to 1, false is equal to 0. And I could do some math on that output, right? So here I get the sum and the mean. So this is going to give me the proportion and the total number of observations where meat is in the product category, right? So all this is meant to do is show you that lots of times when we use these stir underscore functions, lots of times we use them in conjunction with certain dplyr functionality to do some transformation or mutation of our data frame. Okay, so what if we wanted to analyze transactions for all frozen food products? Now, one thing to note here is we have product categories where it's frozen, where it's not completely spelled out. It's FRZN. And then we have frozen where it is spelled out, right? So how do we go about identifying those products that are frozen? Well, one thing we could do is go ahead. We want to replace all these, I don't want to say misspellings, but these shortening of frozen or abbreviated forms of frozen, and we want to replace them with the full word frozen, right? So we could do that with this line of code here. Well, let me just go down to my script. And we can see right here, we are taking products. We're going to go ahead and mutate our product category. and we're going to identify all those where it's FRZN, abbreviated form, and we're going to replace it with frozen. All right, so if I just run this, then what actually gets returned, let me rerun it, see if we can see it, is any instances of just FRZN gets replaced with the full word frozen. And then this code just does some follow-on work where it first replaces the abbreviated form with the full word frozen, and then we just filter for the full frozen word. All right, so what we've done, or what we've been doing, is a very simple form of what we call regular expressions. And often when we talk about regular expressions, we talk about regex. That's just the abbreviated form of regular expressions. And regex is a concise way to identify patterns within character strings. So, for example, take this here, where the first step was to create a new variable where we overwrite the existing product category variable. And what we do is we replace this pattern, this FRZN, with the full form of frozen, so that when we filter for those frozen products, we only have to filter for where it's frozen. Right. Regular expressions actually allows us to write a more concise pattern than what we did here. What we can actually do is we can go ahead and filter, and here I use strdetect to identify any product category that has the regular expression of frozen or FRZN. So what this is doing is saying, look, I want to look in every element of product category, and I want to identify where it either is frozen, spelled out, or the abbreviated form of frozen. Now we don't have to worry about changing the abbreviated form to be the full. And now, what if there were instances where this was case sensitive, right? Where in this case they're all capital. Maybe there's some instances where they're lowercase, right? This is going to be an exact match. What we could do is extend within our regex function, and we could say, hey, look, I want to look for both frozen or instances of FRZN, but let's ignore the case. So if it's capital, if it's lowercase, if it's a combination, it doesn't matter. Just find that pattern of letters, and let's filter for just those. All right, so I want you to put this to test, and what I want you to do is identify how many product categories contain the word fall or spring in their description. All right, so way to do this is we can go ahead, we're going to use filter, and inside of filter we're going to use strdetect. What we want to do is detect those elements or observations where a product category contains the word fall or spring. And in this case, we're going to ignore the case because we don't know, are they all capitalized, are they lowercase, are there some that are title case or a combination? And so what we find here when we do this is all instances, and I can go ahead and let me just run this on my side, and we can see what this looks like for output. All right, here we see product category. Now we have spring, so that was one. And further down, there would be some instances where it's fall, right? And in total, we get 651 products that contain the word fall or spring in their product category. All right, so there's a lot of additional things we can do with regular expressions. For example, we can use what's called line anchors to identify patterns that start at the beginning or an end of a sentence. So here we use the caret to identify all those elements where it starts with fruit. So we can see now fruit is the first word in each of these observations. We can use the $sign at the end of the pattern, and that's going to identify where that pattern exists at the end of the element. Or we can even find a combination, right? So this is look for the regular expression where it starts with fruit or where it ends with fruit. right? So we can combine different line anchors to find things that are at the beginning or the end of a sentence. There is also several different forms of what we call character classes. And character classes are just certain types of syntax designed to identify very general patterns. Right? So for example, we could use a character class here where it's in the brackets, and we specify we want to look for instances where the numbers 2 through 5 exists. Right? So here I'm looking at package size. And so all the package size observations that get returned are going to have a number that includes 2, 3, 4, or 5, right? And we can do that with this shorthand character class. There's other examples where we can look for certain alphabetical letters, right? So here we're going to look for all lowercase vowels. We may look for anything that is an uppercase letter. And here we could use this to match anything other than the specified numeric values. So there's lots of different examples of these character classes. Check out the lesson reading. They go into a little bit more detail and show how to apply some of them. Another form of character class are these very shorthand specifications where you have 2 escape characters before a certain letter, right? And these will mean each of these will stand for something specific. For example, if we do double escape here and then a lowercase d, that's going to search for, in this case, any product type that contains a digit, like a numeric digit. So we see all the elements that get returned have some numeric digit in them. And there's other ones, like 2 escaped signs, and then a capital D looks for any non-digit. We can identify space characters, or we can match words. There's many different examples, and again, I list many of these in the lesson reading, so check that out. We can also do things such as identify punctuation, right? So here is a character class where we're going to look at product type, and we're going to look for, within product type, any instances of a punctuation. So this is shorthand to say find any punctuation, whether that be a dash, whether it be a period, a question mark, a colon, or what have you. And you can see all the observations that get returned have some form of punctuation in them. And there's others. We can find any lowercase letters. We can use this to find any digits. We can use this to find any blank characters, which would include a space or a tab. And there's many other examples that I include in the lesson reading. And we can also look at repetition. So sometimes we want to look for a certain pattern, and we want to look how it repeats so many times. For example, we could use this plus sign, which means match a preceding pattern 1 or more times. So in this case, I want to look at the product ID and identify those product IDs that have 1 or more 8. So we want to identify where 8 is in the product ID 1 or more times. All right, so all the product IDs that are returned, we have 8, the value 8 in the product ID 1 or more times. We can use this curly brackets with n and specify exactly how many times. So here we want to find those product IDs where 8 is matched 2 times. So we can see we have 8 in all these cases 2 times. Now you see in some cases there are 3, but that's because these all have at least 2 instances of 8. And then we can also do match a preceding pattern of n up to m times, right? So in this case, we're going to look for the pattern 8, 7, where that repeats from 2 to 4 times, right? So in all these cases, we have the pattern 8, 7, 8, 7, 8, 7, 8, 7, 8, 7, 8, 7. So all these product ID numbers has the value 8, 7, that pattern repeated at least 2 times and up to 4 times. Now, one thing to kind of point out is that when we are searching for a specific non-alphanumeric symbol in our regular expression, we need to escape it. What does that mean? Say you want to search for any instance of the dollar sign. Well, the dollar sign is used for a specific purpose in regex. It is looked to identify any pattern at the end of a sentence. So for us to tell R that the regular expression we're actually looking for is literally the dollar sign, we need to escape that. And we do that with two escape, basically two escape symbols. Another thing to do is say we want to look for, in this case, an opening parenthesis. Well, parentheses have a certain meaning within regex. So in this case, we're saying, no, I want to literally find an open parenthesis somewhere in that character string. So we need to escape that open parenthesis. All right, so here's what I want you to do. I want you to pause this and see if you can put some of this information together. You may need to take a look at the reading to kind of help out with this, but I want you to identify all products that are categorized, which this is product category, as pizza, but are considered a snack or appetizer. So I want you to use product type when trying to identify a snack or appetizer. Which of these products have the most sales measured by quantity? Okay. So hint, you'll need to join to the transactions data, right? So several steps going on here. Take a few minutes and see if you can figure this one out. Okay, well, I hope you worked through at least some of this. I'm going to show some example code here. All right, so we start with products. And let me just go ahead and enlarge my console here. We're going to start with products. And in this case, what I do is I want to just select the certain variables of interest. So what we care about is product ID, product category, and product type. Right. So the first thing we can do is, let me paste this. So first, within filter, what we do, the first step is just filtering for all those where product category has the word pizza in it. And we're going to ignore the case, right? So now we have product category and we see we have pizza in all those elements. But what we wanted to do was find all those product categories that are pizza, but are considered a snack or appetizer based off the product type. So what we can do then is we can actually add another filter statement here where this first one is going to identify where product category contains pizza. And then the next one is going to identify where product type contains either snack or appetizer in the word. And if we filter that, now we see product category contains pizza and product type contains snacks or appetizers. And then from there, what we can do, we join to transactions, we group by the product ID, we get the total quantity purchased for each product ID, and then a range. And we can see that this 845193 that's the product ID with the largest amount of quantity, which is 42. All right, so here's the thing to remember. Regular expressions are overwhelming, right? Rarely do you ever actually remember regular expression syntax other than the most simple and basic forms. I'll tell you one thing, every time I have to do regular expressions, I am Google searching how to do a certain expression, right? These are not easy things to remember, and a lot of the regular expressions are very dense and confusing combinations of letters, symbols, or whatnot, okay? So the main goal I'm trying to get across here is that you understand at least some of the basics. You understand what regular expressions are and kind of how to implement them, but don't worry too much about knowing all the various, character classes and anchors required to do regular expressions. I would totally expect you to have resources open online to reference as you are working on your regular expressions. All right, key takeaways here. StringR, it's a package that is fantastic for analyzing text. All the functions start with stir and then underscore. If you're going to look for a specific regular expression pattern, we use regex function inside of whatever string R function we're going to use. We can use line anchors such as the caret and the $sign to identify patterns at the beginning or end of a line. And there's many different character classes, such as ones that we see here, that can allow us to identify some more general patterns that exist, such as identifying punctuations or identifying ranges of numbers within, or ranges of digit numbers within our character string. And we can add different syntax, such as this, to identify repeating patterns if we want. And anytime you're looking for a non-alphanumeric value that's kind of unique, but is also used in regular expressions, such as like a $sign, we always have to use the escape clauses, this syntax, this double backtick, in order to tell R that, hey, look, we're literally looking for this symbol. We are not using the regular expression form of it. All right, so like I said at the beginning, this is just a very quick overview of strings. The reading lesson actually goes into far more details, has a lot more code examples, and gets you working more hands-on with these different types of regex expressions. So go ahead, check that out, start working through the code, get comfortable typing in some regular expressions. And if you have any additional questions, hit up the discussion board on Canvas.